You're sitting there doing nothing. That doesn't look too good. Directions on the board are super clear already. What you need to be doing. I should have hoods off, electronics away. Yes, you did. Right now what you are doing is opening the 2 files that it asks you to that are under downloads on Jupyter. You will be doing some notes today. Go. You've got your notebook out, you've got the 2 files open. All right, so you should have those files up already on your computer. If you don't, I'll give you a little more time to get them up when we get to them. All right, here's where we're at for today. So we did yesterday linear correlation. Today we'll talk about nonlinear. Because as you know from algebra, you can't always fit everything to a straight line. All right, we'll get on Desmos. We're going to start talking about R squared, least squares, which some of you already addressed in algebra this morning. Reminders, finals, they're in 15 days. So think about where your grades are, what you need to do between now and then. You may need to start making a list. These are the things I need to do in the 15 days that are left between now and finals. Okay? We'll start reviewing for your algebra final probably next Tuesday, if not Monday. All right? Module 2 on Alex is due next Saturday. Statistics test and project are also next Thursday, Friday. Probably will not have too much time for that today. You will have time on Friday in here. All right. Questions related to this or anything we're doing today? All right. So your focus is up here. Remember, the camera's on me. The camera is not interested in what you're doing besides the fact that you are doing what I'm asking and you are engaged in answering questions and asking appropriate questions. All right? All right. So everybody's answering. You are not writing these. Positive, negative, or no correlation. This is what we talked about yesterday. What type of correlation?
Positive.
Positive. Is it like a super strong positive or is it sort of weak? It's almost approaching no correlation or scattered, yeah. There is a positive trend to it, but you can see there's quite a difference between the points and the line, all right? Which you'll talk about. Those actually have a name. They're called the residual. So yeah, it is a positive, but it's not very strong. What about that one? That's definitely no correlation. It is all over the place. Okay, how about that one? No correlation. That one's pretty random again. Next one? Negative. It's closer to negative than none, but yeah, it is not super strong. Good. And that one? Negative. This one is definitely more closely aligned to a straight line. So that's going to be more strong of a negative. And last one?
Positive.
It is positive because it's increasing. And again, that's not too good a line of best fit. How about that? Okay, because the data is pretty close to that line. Okay, so it's pretty even. Questions on these? All right, so nonlinear. Yesterday we talked about linear. The 2 other nonlinear pieces you talk about in Algebra 1 are your quadratic. So if I draw the curve of best fit, because we can't really say line now because it's not a straight line. But if you have to describe that, how are you going to describe quadratic? What does it look like? A parabola, or in everyday terms, a U. Yep. If you know the term parabola already, fantastic. It is what?
Rainbow.
Or a rainbow. Yep. Exponential. I don't know what I would call that.
A wave.
A wave, a slide. It's a curve.
Looks like one of those ramps or skateboards.
Okay, a skate ramp, a snowboard ramp. Yeah, I guess I could see the ramp. Like, I don't skate, but when I would be at Woodward Camp, they had lots of different ramps for the skaters and the BMX and all of the above. All right. So there's in one place. That's what I want you writing down today. 3 types of regression. And sketch them real quick in your notes so you have them to look back on in one place. So jot those down in your notes. That's the only thing that's going in your notebook today. So why are you skipping ahead?
Because I did my notes back. I put my notes in the back.
Okay. All right, couple more seconds.
I still need to learn one.
Yep. All right, I'm going to skip ahead. If you're not done yet, I know your neighbor has it done, so you can look off of theirs if you need to in the meantime, and I'll go back to this at the end. Okay, card sort. So you each got a strip of paper here with 3 graphs on it. So find that. Everybody's looking at this. RJ, you got this? Okay. First thing you need to do is you need to identify each of your functions as linear, quadratic, or exponential. Yes, you can abbreviate. Then, using a colored pencil or marker, preferably a marker. You should have some markers in your bin. Draw the best fit line or best fit curve for each. Remember, we're not connecting the dots. Yesterday, we had some of you that were still trying to connect the dots, so we're practicing again. All right? That's as far as I want you going so far. Okay, so on your 3 graphs, identify as linear, quadratic, or exponential. You may not have one of each. And then draw your curve or line of best fit. Do this first, then you can go back to that. So identify and best fit curve / line.
Wouldn't this be quadratic?
When it just goes in one direction?
But it's curved.
It is curved, but we talked about one that's curved that,
Oh, that's been.
yep. Okay, Sunny, exponential. Do you know what you're doing?
Yeah, we gotta identify each
Okay.
of them.
Get them done. Yep, and you can just label which one is which. You can just use the first letters, L, Q, and E if you want. Okay, I'm just going to stick tape there for your group
What's it for?
for the next step. Looks good to me. Good? Okay. You should be good with that. All right, anybody need another minute to label them and draw your curves of best fit? And make sure if you're standing up, make sure you're just careful with the camera there. All right. All right, your next direction within your row. So I think I have at least 2 to 3 in every row. Yes, so we're good there. 2s are fine for this. You're going to sort them into 3 categories. Let me finish instructions before you move. So you'll, within your row, make a pile of linear functions, a pile of quadratic, a pile of exponential. So there may be some where you look at it and your neighbor said this is linear and you're like, I don't think that's linear. So I'm hearing that dialogue back and forth. This is why I think it's linear. This is why I don't think it's linear. Okay, once you've agreed and you have your 3 piles, you've got some red tape somewhere in your row. You need to bring those linear functions up, tape them to the linear section, quadratic and exponential, all right? So you are tearing the tape apart into smaller pieces, all right? So you will cut the graphs apart. You've got scissors, or tear them, that's okay. Agree on which ones are linear, quadratic, and exponential. Get them up on the board. I would like this to be done in about 7 to 8 minutes tops. Questions? Go for it. Okay, so you can cut or tear them apart. They're just 2 straight cuts. So just get this done, then you can go right back to that. So within your row, so you and Sunny are going to cut these apart and then decide, make sure you agree, like that one's linear, so collect all the linears, put them up there. Collect all the exponentials.
Do we tape them together? Like,
Just, you can just cut them into little pieces, tear them into little pieces
what are we using tape for?
to put these on the board.
Oh,
The
So
whole group has to put them on.
cut these apart, so bring your page over here, cut them apart, and then stick them in the correct place on the board. There's a little more tape that's already torn. Bless you. Okay. Oh, if you want to, you can do it on your own. I didn't specify that you guys were a group. That's okay. Or if you just want to put them up. I think you're good. Oh. Oh, my tape is not cooperating. There you go. Sorry about that. All right, my big group is going. Go. Just looking. Okay, so you got them apart. Do you have oh, you got it at the top. Good. Okay, so linear, linear, exponential. Oh, you already put yours up? Okay. So do you want to check them with Seth, make sure he agrees, and then you can put them up on the board?
Sure.
Okay. Then you guys still have tape? Yeah. All right, they look good so far. They're all going up. Yep, they're labeled. Curves and lines are drawn. Yes, yep. Yep, you're putting all the papers up there. So by the time you're done, you should not have any graphs left at your desk. Got them? Do you need more tape or are you good?
we're good.
Good? Okay. Oop. Good, Kate. Catch.
I'll get into music.
Okay, good. Okay.
Exactly.
Are we just about there?
I thought you were always.
There's one more piece of tape. All right, you're finishing up in about the next 30 seconds. I got just about everybody done. Look good so far. Good, good. Okay, I got all my quadratics and my exponentials. Good. Okay, they all match. So I have these up here for a reason, because as we're going through the next piece, you may forget which one's which, and you're trying to compare, well, which one looks like it might be linear versus quadratic versus exponential. And if you're seeing these on the front, you have instant reminder as to which one's which, all right? And you notice some of them are super obvious. Like these are pretty close. Okay, it's pretty obvious that's quadratic. You will have some, when we're working with our data in a minute, that it's a stretch to call one of them linear, quadratic, or exponential, all right? But for today, I'm going to say you have to pick your best model. All right, questions here? Most importantly, I'm glad I don't see anybody connecting the dots. So when we skill quiz next week, or you do something in algebra next week, like a test or a quiz, we better not see anybody connecting dots. Okay, scatter plots, you don't connect things with dots. All right, moving on. So the reason we're doing this is in real life, you do have a lot of things that are not necessarily exactly linear or exactly quadratic or exponential.
What are widgets?
So widgets, it's a piece of something, so they can use it as a generic term. It's something that they're using in a factory, so a part of something. So the cost per widget produced by a factory generally drops as more are produced, but then it starts to rise again due to overtime and wear on equipment. So up until a certain point, the more I make, the better it is. But then you hit that point and you're like, oh, okay, now it's getting more expensive again. So my cost per widget is going down, and then it starts to go back up. Which one of these shows that it goes down and then goes back up?
The quadratic.
Quadratic. So my quadratics can go down and then up. My linear only get to go up or down. Likewise with my exponential. All right? So right away, because of this change in direction, I know it's going to have to be quadratic. All right? You could plot these on a scatter plot, and you'll get something like this. There's my data points. That's a pretty small sample size. All right? You could calculate the equation by hand. I don't think you want to. And right now, for semester algebra 1, you don't have the skills you need. But if you do it with a calculator, there's the equation they get. And when you plot that on Desmos, okay, it shows there's my curve. So you can see that there's very little difference between the points and the curve. All right, it's pretty accurate. And in the summary on Desmos, they give you a statistic. They give you R squared. Okay, R squared is what we're focusing on today. I want you to draw a conclusion. So I'm not even giving it a name yet, besides it's R squared. Yes, I know some of you talked about it in algebra this morning. So you can use that information to help you. But you're still answering the question as I'm phrasing it. All right? So I'm not interested in you spending your time typing numbers in. So I have everything in Excel. You're just copying and pasting. And my goal is I want you to figure out, how is R squared, the value of R squared, how is that related to my best line? Like, you can look at this data and you know it's quadratic, but you can make it be linear. You can put a line of best fit that goes like that. Does that really match the data? No. You could do something that's exponential, but that doesn't really match it either, all right, because it's got that turn. It goes back up, all right? So you're going to have 5 sets of data, and you are going to actually plot them on Desmos, see what you get, and decide which is best, linear, exponential, or quadratic. All right? So to do that, you've got those 2 files open. You've got your Excel data, okay? And it should be on example 1 already. Notice at the bottom here, example 1, 2, 3, 4, and 5. And you've got Desmos open, okay? So you have, this is the syntax, the format in Desmos for your linear, quadratic, and exponential models. So what you're going to do is you're going to paste your data in. All right, now, Desmos does not like right-click paste. So you're going to copy your data in Excel, and then you actually have to use the shortcut Control-V, paste your data. All right, so I'm going to come back and do that from my computer. You keep listening and watching. Okay, so I went to Excel. I highlighted, I right-click, copy. And then I go to Desmos, click in the blank line, Control V. And maybe it goes. Let's try that again. Okay, now if you look at where my cursor is, X4. You need to change those back to X1. So I delete the 4, I put a 1. Go back down to your data, delete the 4, put a 1. All right, now when you look at your graph, which one matches? Does that look like it's exponential, quadratic, or linear? Exponential, my orange one, all right? And if when you pull it up, it doesn't show you all 3 lines, scroll up to your equations and just click the line, the curve, so that you see all 3 colors. Okay? Now on your data chart that I'm going to give you in a second, you are going to, on the back, actually write down your r-squared values, which are right here. Here's my r-squared for my linear. Here's my r-squared for my quadratic and my exponential. Okay, so let me go there. And okay, so let's see. For my linear, it's 0.916. For my quadratic, it was 0.99. And exponential was 996. Which one did we say is the best model? Exponential. So I'm going to highlight or box or star something, my best model. Okay? Then you go back to Desmos. You have to actually close out your data. So it did it for me. If not, just click the X, get out of it. And then go back to Excel. Change it to example 2. Copy the data, put it into Desmos, change them back to 1s, do it again. All right? By the time you're done, you have every r-square value, and you have a best model chosen for each of the 5 examples. All right? Questions on this? All right. I do not care whether you work with a person in your row and do it on 1 computer or do it on 2. All right? Once you are done with this, let me know. You can start trying to answer the conclusion questions at the bottom. All right? My entire goal with this is, how is r-squared related to the best model? If I see my r-squared, can I tell which one is best? All right? All right, let me pass these out and then unlock computers for you. There we go. Please stick a name on it first so that you do not forget. There you go. There you go. Oops, I think there's an extra there. There you go. Mm-hmm. All right, so I'm putting example 1 back up so you can see it if you need it. Remember, Control V is the shortcut for paste.
So you put in the data, then you find which one that is, but where do you get these numbers
So when
from?
you do the data, so we'll do example 1. We already did that. That's okay. So if I write, Control V, okay, change those back to 1s. So just click into a new line, just right below it. There you go. Scroll back down. Oop, okay. Okay, so now if you scroll up, so click those so that you see them. Yep, so now which one looks best?
Yeah, that one.
Mm-hmm.
Oh wait, so you just
Yeah,
like
so
that?
it gives you your R squareds.
Okay,
Mm-hmm.
thank you.
Yep. Gabby, you good? Okay. There you go. Okay, so if you flip this over, so there's where you're writing your R squared values for each.
So then we could just write on one paper.
Write it on both because it'll end up being your notes eventually.
Okay.
So if you copy this, right click, copy, then go to decimals, new line, just click, and then Control V. Okay, change those 4s back to 1s. And then scroll back down. Change that one to a 1. Good. And then if you scroll up, so it's got your exponential on there, so come over here and scroll up. Click the other 2 circles so your lines see. Yep, scroll back up, it keeps bouncing. And the top one, there you go. So now you can see it's the exponential one. And then your R squared values are there for each of them. That's all you're writing, the R squared values. And then exponential was the best, so write it down. I'm not telling you what R squared means yet. I want you to figure something out about it.
Like, so just write what it equals.
Yeah, just write down the R squared values. And the exponential is the best. It'll make sense at the end, I promise. Oh, you gotta change your Y4. Make that a 1. Did you change the X, or is that still a 4? Okay, so scroll down, make the X a 1 as well.
What do I do from here?
So is this the first one?
Yeah.
Okay, so click them all on so you can see them all.
Mm-hmm.
Now, if we zoom out a little bit, keep going so you can actually see all of it. Which one looks best?
Exponential.
Exponential. So exponential is the one I'm writing for the best. You can just abbreviate EXP.
Right here?
Yep. Okay, and then you're writing your R squared value down for each. So for the linear, right here, y equals mx plus b, write down your R squared, 0.916. Yep. And then quadratic is here. And then exponential is there. So which one looks like it actually represents the data the best? Which color? Orange or purple or black?
Orange. No, purple.
Purple, because the red points are your data points.
Yeah.
So which one's purple? So you can scroll back up here and look.
This one.
Yep, which is your quadratic. So quadratic is your best.
Thank you.
Mm-hmm. Gage, you good?
I was asking him a question.
Okay,
I just asked him.
you got it? Okay.
Did I do something wrong? 'Cause
Nope, you're good.
none of them were, like,
One of them is perfect. So I see orange data points.
yeah,
Which line goes through all of your data points? Which color?
black. Goes through one. Oh,
You're overthinking the easy one. Show me your points. Point to your data points. Okay, so which curve is that?
quadratic.
Uh-huh. So there's your linear R squared that you're writing down. Oh, you wrote the wrong R squared down, that's why. R squared is 1. You wrote down your A value. Write down your R squared for each.
Good, is that for all of them?
Nope, just that one. Okay, so you've got yourself zoomed in so far that you're not going to see. So you're up to 50,000 there. So let's just change this back to like -20 to +20.
Oh, I didn't even touch it. That's not like, what the heck did I do?
Well, you can scroll, and so you probably scrolled without realizing it. Oops, it didn't go. Which one didn't go? Oops, that's -2. Let's make that 20. +20. See, because if you go here with the scroll bar, so you were probably trying to go down here and you accidentally scrolled out.
So then these are still the same thing.
Yes.
But can it be the black?
So I'm going to say for that one, just go ahead and pick whichever one you want. When you get down and try to make a conclusion, you're going to realize. Is that a hand? Not sure.
Yeah.
Okay.
I don't know what to do after we do this. I'll erase that and write it 2. And then keep
Nope,
going.
so actually X out of the data chart. And then did you copy example 2 yet? So change this to example 2.
Right here.
So you might just make this big. And then go to example 2. And then copy that data. And then go back. Keep everything X1, Y1. How you doing, Brittany? Good? Okay, so, yep, you've got everything in correctly, but you can't see your data. Because look at where your scale is. You're up to like, what's that, 20,000 or 200,000? So if you go to your wrench there, change your X and Y back to like -20 and +20, -20 and +20. Then you should be able to see something. And you can use the keyboard or their keyboard.
Got that part right.
Yeah.
Oh, you somehow managed to get out of the link. So you are missing the, we can fix that. Let's go to this one. Because I put this piece in for you. It's going to not cooperate like these. So let's just copy this. It may or may not copy nicely.
It's still saved in the copy paste thing, so you
Okay.
can just copy it over.
Oh yeah. Okay, so change those back to 1s. And then you have something to click.
Wait, change.
Where it says X4 and Y4,
Oh.
change those to 1s. X1 and Y1. Yep, you gotta scroll, you gotta use the back down. Yep. Okay, so now if you go up, scroll up on the scroll bar, yep. Click your 2 other wavy lines. Yep, go back up and click it again. It's doing that weird thing today and I'm not sure why. So now you have data you can look at. Okay, where's your way too far down? We don't have that much data. Okay, yep, so go all the way back over. So just copy the data. Okay.
Okay, I was having problems and I was just gonna do a pilot since I don't know what to do. I can't find it.
Okay, the 2 things you pulled up for bell work. You had them up before. Okay. Sunny, are you done? Sunny. Open the 2 links that you were on for bell work. Your bell work. So open the 2 decimals things. So did you get into anything for bell work, or did you just ignore my directions for bell work?
Know your directions?
My bell work that was on the board that we talked about. You should have 2 things open. Okay, so flip over your directions for your worksheet. Read step number 1 on your worksheet. Flip it over to your directions. Read step 1 and follow those directions. So now once you go back to Jupyter, you got to open your Excel. So yep. Okay, yep, so copy that and then keep going.
Will this be quadratic or exponential?
So are any of them really close?
No.
No, so I'm going to say pick the one you think is the best. I know none of them are really there.
Should we go by R squared or?
For now, you can go with however you think. And then once we talk about this, you may want to come back and change that answer. Yep. Yeah, go ahead. Where are you at?
I'm still stuck. So I don't know how to get those lines.
You deleted all your stuff.
Oh.
Okay, so now paste your data. Change those to 1s. And then go. Are you done? No. No, close out of Alex. You're only where you need to be. So follow your directions, fill out your data table.
There's only one circle.
I can
So,
zoom it out. I only
yep.
saw one circle, man.
Nope, if you keep going, because you're still at 10,000. So keep going.
Keep zooming out?
Yeah. You can also, no, you're going the wrong way.
That's
What was that? Oh yeah, you got to zoom in.
I'm sorry.
Other way is you can see the wrench.
Oh, the wrench.
So change those back to reasonable numbers, like -20 to +20, -20 to +20. Done?
Yeah.
So what did you decide for r squared?
I said that it relates to the number that it touches. I think.
Okay, so what I'm looking for is how can you, if I didn't give you the graph, I just gave you those numbers, how could you tell that exponential is the number 1? What do you know about the r squared value?
Greatest?
It's the greatest. So is that true for all of them or almost all of them?
Almost all.
Okay, which is the only one it's not true for?
No. Yes. This and this.
Okay, and
And this.
these are all the same. So it is the greatest, it's just, so they're all the same, it doesn't really matter. And then this one, number 3 was the one where none of them were really a good fit.
Yeah,
So you had to pick, but I mean, 0.2 points, is that 4?
-9.
9? I didn't think those were 0.9s. Might want to check that one.
But may I go to the bathroom?
Yes, go ahead. Yeah, because Gabby did not get on 3. We should get some really crazy numbers like 0.2, 0.7, and 0.1. So go to the restroom and then fix number 3.
Okay.
All right, you got about 2 more minutes. Yes. Okay, Caitlin, I'll be there in 1 second. Good? Okay, so now can you start thinking about those questions? So try it first and then we'll talk about them.
Okay, this one, I'm so
I think
we are
this is
so
a trick
confused.
question.
This is like a trick question.
It kind of is.
I think it's undivided.
Because then
If I said you had to pick one of them.
Actually,
I'm gonna still say exponential.
I would
Exponential, quadratic, or linear?
I say linear.
Okay, go with it. It's not going to matter in the long run for this one. Almost done?
I need help with this one.
Okay, so none of them really match. That's okay. If you had to pick, which one is close?
Closest
The
to what?
closest to representing the data.
Wait, is there a right answer?
a right answer for the formula.
Yeah.
The exponential one.
Okay, so write exponential. You may end up going back and changing that one.
Alright. Is this correct?
Good so far. So you are on the second one. So now you got to decide, you've got your R squared values.
Alright.
Which one is the best model? Which color?
Quadratic.
Quadratic, good. So write quadratic or Q for quadratic, whichever you want.
Say right. This there, right?
Yes.
Alright.
Okay, and then remember we want to circle it because that's the one we picked, because we're going to try to make some conclusions about the R squared values in a minute.
Yeah.
Okay, so see if you can get example 3 done. So close out of your data for this one, and then copy the next one in.
This would be better to be linear because it goes through all of them, right?
Yes, you can do that. Caitlin, oh, okay, I thought you were turning that in. I was going to say hold on to it. Good, good, good.
I don't know if I got this all right. 'Cause
Yep, I'm good.
was
It looks like it.
number 4 right, 'cause then 99.
They were all the same. Good.
Okay.
Yep. Okay, so start thinking or start writing something down for those, and then we'll go over them in a minute. Okay, who needs about 2 more minutes? 2 more minutes? Okay, we'll go 2 more minutes. At 11:20, we're going to start talking about them because we got one more thing after this. Okay, so r squared. So if this was exponential and this was quadratic, what are you noticing about the r squared values that you picked? Are they biggest? Are they smallest?
Or, well, they're bigger.
The biggest. So these 2 were pretty clear that yes, these are the best models. Number 3 was the one where we said, well, it's not really any of the above. So could you agree that I guess that is the best one, even though 0.7 really isn't close to 1? Yeah. Okay, so, but that's what you're putting here. The bigger the r squared, the closer to exact it is. Okay, Adam, you good?
I guess, yeah.
Okay, so if we're looking at question 1, which type of regression must always increase or always decrease? So looking at my board, linear.
Yeah.
Does that go up or down?
It goes up and down. Well, no, it goes up.
Right, so each one goes up or it goes down. It can't do both. So that's 1, linear.
So
All
you
right.
can't do what?
You can put linear, yep, for number 1. Are there any others that just go up or just go down?
I don't think so. It stays up.
Quadratic stays up, but if you trace it with your finger, it goes, if it's going this way, which way is that?
Downwards,
And then,
upwards.
or it went up and down.
Also, it still goes up and down.
But it does both. So that's number 2. It goes up and down.
Okay.
How about exponential?
It goes down and goes up.
Does it do both in the same line?
No. So it's linear and exponential.
Yes, very good.
Did you need to
You can try. Yep,
exponential, linear, and then quadratic, and it's closest to the biggest?
you got it. Good. All right, 30 seconds or so. Finish up the one you're on. Do not start a new one. It froze. Well, it froze at a good time because you're done with the computer for what you need. Is everything frozen or just
Everything.
because you were scrolling so far in and out? That's why. Okay, will it close out now? Okay, do Control-Alt-Delete, get out of that. Actually, I can leave it there. All right, stop where you are. Make sure you can see my screen. If you moved, make sure you're back to where you can see. I am not going to go through and fill out the data chart with you. Okay, I'm not interested in those specific numbers. Walking around, you saw what you needed to see. I'm seeing the conclusion there, even if some of you can't put it into words yet. So, question 1 and 2, there's no easy way to word those, so they're kind of wordy. They're not the greatest. But I want to know which type of regression always increases or always decreases, meaning it only gets to go one direction. So for it goes up or it goes down. It can't go up and down. So which ones go just up or just down? Linear and exponential. Because we can go up or we can go down. Okay, and then number 2, which type or types of regression increases and decreases within the same graph? Quadratic, because it either goes down and then up, or it goes up and then down. Okay, it makes that rainbow shape. Okay, and now number 3, that's the whole point we're trying to get at today, which if you did not get through all 5, that's okay, because you probably started to figure something out and you were having a good discussion about one of the earlier problems. How is R squared related to the one you choose for the best model?
It's the
Dylan? So putting it into words is where we're struggling. So if I want to pick the best model, I need to look for the R squared that is what? The biggest. So the larger the R squared, or the greater the R squared value, the more accurate the model is. Is there a maximum for an R squared? Okay. I'll leave that question to you guys to figure out in the next day or two as you start talking more about regression and residuals in algebra. Okay? Maybe there is a limit. Right, that's what our R squared comes back to. R squared is your residual squared. So if we're squaring something, can it be negative?
No.
Nope. When we square it, it has to be positive. So it'll start at 0. Which makes sense because one of these, you actually had a R squared value of 0. So that says there is no relationship. There is no way you can make a model follow this. Okay, that's what 0 was. For example 2, you had a 1. That meant it's a perfect model. If you looked, that was like our example here, where every single point was exactly on the line. Okay, so maybe there is a limit for r squared, because if this is perfect at 1, can we go above it?
No.
Okay, we're thinking no.
I'm just kidding.
You tell me by Friday if there is or isn't a limit. All right? Questions on this? I need your worksheets just to see where you're at, so make sure your name's on it. Pass those to the center. I have one more set of directions for you, and you've got about just over 10 minutes. It's a Wednesday. Yeah, 11:38. That's what we just talked about. All right, so the next 10 minutes, you are doing one of a couple things. First, if you have not finished your data chart for your statistics project, that's what you need to do first. Remember, you should have a data chart that has the year, the men's gold, women, or gold medal time or distance, and then the women's. You need at least 10 data points or 50 years, whichever you want to say. So if you start from like 1968 or thereabouts, how often do the Olympics happen? Every 4 years. So if you start there and go to 2008, which is where your chart goes to, you will have what you need. All right? If you're done with your data chart, take it out. Let me see. I want to see where you're at before I let you move on to the next step. All right? Questions? Yes. All right, make sure papers are at the center. Go ahead, get going on that.
Oh, sorry.
1, 2,
What's your name?
3. Okay. Papers, guys. Thank you. Okay, you got at least 10?
Yeah.
Okay, so next up you need a scatter plot. So grab yourself a piece of graph paper. It's in my lined paper bin.
Okay.
And start making your scatter plot.
I don't know how to make one.
Okay.
Never gone over that.
We've done, it's like what we just did. So draw your axes lines, like a big graph, and start getting a scale going. Go get paper and a ruler. I'll help. Thank you. Papers, guys?
We're supposed to put our name on it, right?
Probably. Thank you. Kayla, you got your paper? Oh, you're finishing up there. Okay. Thank you. Thank you. Let me see where you're at.
I don't know.
Okay. Just stick it in the basket when you're done. Okay. There you go.
Thank you.
Is that going to be scratch paper or?
Holding it.
Well, all your data is in the first quadrant, so you probably want everything in quadrant 1. So give me a piece of scratch paper so I can show you what you're doing. That works fine. So you want to make yourself a big graph. So like you're going to have your grid lines all the way over here. Put your year on the bottom, and then the times on this side. So you did something, so everything's in seconds. So your years need to go from 72 to 2008. So pick a scale so that like you cover most of the graph. So maybe every 2 boxes, maybe every 3. Okay, and then you got to go up to 11 seconds, 12 seconds.
That's 11.
11?
Yeah.
Is that 110?
No, that's just.
Okay.
I don't think that they could do it in 110.
I was going to say, they would probably start over. So maybe by like 1 second, 2 seconds, 3 seconds. Okay, and then so 2008, 9.64. So you go over to 2008. I'm going to pretend up to, well, 9.68 would be beyond halfway. Put a dot. So do all your men, and then I would color code them.
Graph plot, pretty much.
Yes. So you do that one, and then 2004, 2002. Don't zigzag, don't connect them. But do all your men, color code, then do the women on the same graph. And then
In
you'll have to,
different colors.
yes. And then that's where I want you by the time you get to Miss Andrews' class tomorrow, so that you can
We're supposed to be
do the
working on it
calculator
today
part.
in class, I thought.
Are you? Okay.
I think so.
I don't remember. I thought we had lesson 8 to go today.
Well, lesson 8 and then the rest of them.
Okay. I don't know how much time it's taking. But if you've got your data, that's where people get hung up. Okay, where's your data? Okay, Geneva, you got a sport that you picked?
Yeah, but like, because like, because we didn't want and they wouldn't get food. So then I found it.
Okay, so I would pick, are you going to pick them and email them to her?
I think so.
Okay, do that now so that you can have an answer by tomorrow. Okay, Caitlin, you got your data picked?
Yeah.
Where is it? Let's see.
I got mine done.
Jahan,
my graph
data?
done.
You did it yesterday in tutoring. Let's see. No, I know you have yours done. You don't have to get it out. You can work on Alex.
What?
Did you finish your data last night?
Yeah.
You did?
But I accidentally threw it away because I thought it was for Algebra 1.
It is for algebra, but you're not done with it.
She told me not to, because someone already got that topic. She said,
Miss Furman?
I thought she approved it when she was over next to you.
Smack someone?
but she said someone else already had it.
Can I just like backhand him? I really want to.
Why would you do it?
So did you pick a topic this morning when you saw Miss Durinsky?
But she said someone that had the topic like damn.
Okay, so did you pick another one?
I'll not do after school today.
Yeah, he's staying after school.
I didn't get that paper from Miss Gannis because I was
Okay, pull it up on Jupiter. It's under my name for Jupiter.
11:30, right?
11:38. It's Wednesday.
It's like, you know, did you,
Yes. Mm-hmm.
Red color.
Can I pick this topic?
Okay.
And then what class hour you have her? Thank you. Do you guys have data already for your algebra project?
Yes.
Yes?
I had that yesterday.
Okay, but you have a data chart all set up with your 10 points? Like your 10 times or 10 distances?
Get the data notebook and then put it on the dot plot
Not a dot plot,
or
a scatter plot.
scatter plot. Sorry.
Okay, but you have the chart already done?
Yes.
Okay, but that's not with you now.
Because I have it in my program, I have to get it.
Okay, then start on Alex now. Okay, so you're going. Okay. Did you pick a sport?
Yeah.
Okay, yep. So you're getting back there so you can copy stuff that. I don't know if Miss Webster was saying no duplicates or not.
Because this is what it says on the paper. Because I spent like 30 minutes last night just trying to find a freaking sport that has like distance
Was she,
and elevation and time.
because I was asking this question in tutoring yesterday and I only had a couple people that had Webster and I wasn't getting any
Answers.
confident answers. When she gave it to you, was she going around and marking down who was doing what topic?
Yeah.
Yeah.
Yes? Okay. Because I asked her last night and she didn't answer that part of the email. But it was
hate
after
when people
basketball,
do
so
that.
she was tired. Plus, I had like 15 things in the email, so it was my
I
fault.
get that.
But I would ask her, or
Okay.
maybe I'll ask her because I'll see her first. No, yeah.
I had her first hour.
You have her first hour. So you have her tomorrow morning.
Yeah.
So you can
But
ask
I
her.
don't- Isn't she absent? Isn't she not here?
Yeah, she is. Okay, so I will ask and I'll get an answer and get it over to Red One so you guys know tomorrow.
So, Miss Gannis, do we pick?
You can pick. Yes, you
or
pick.
Are they giving them?
No, you pick.
Okay, and where is it at?
Go to my class, go to downloads, just where you were before. And it should be the top thing, or second, Algebra 1. Yep. Okay, where's your data for algebra? Get it out. You got what you need? You know what you're doing? And you got at least a whole bunch of years there. Yes, you do. Okay. Okay, we can be done there.